Welcome back. This is the second of the 2 tea sessions that we're having today. I'm Pawan Biram. This is my co-chair, Lou Berger. Our secretary is remote, Matt Hartley. We did manage to finish all our sessions slots on time in the first session, so we can jump straight to the agenda. Before we do that, quick look at the notewell. If you aren't familiarized with this yet, please do get yourselves familiarized. There's a link at the bottom that should give you sufficient details. Anything that you say here in the session or on the list is part of the public record. So we are streaming both audio and video. So for the benefit of folks who are remote, please do use the microphones and please do state your name before speaking. As always, we're using Etherpad for collective minute taking. Please do join us there and help us take accurate minutes. We're also on Jabber. And for those of you who are remote, if you have anything to add to the conversation, please jump on the Meetup queue. With that, let's jump to the first presenter. That would be Jaedong.
Okay, good afternoon, everyone. This is Jaedong from Huawei. I'm going to give some update about the framework for enhanced VPN or VPN Plus on behalf of the co-authors. Okay, a little recap of this document. Basically, this document describes a framework for the VPN Plus. The purpose is to meet the requirements of the 5G network slicing, and it can also be used in other generic scenarios, so it can be relatively decoupled and generic. In this draft, it defines a layered architecture and also give analysis as to candidate technologies in different planes and layers, including the enhanced Android data plane. Several mechanisms are described which can be used to provide different levels of SLA guarantee. And for the in the virtual network layer, we can consider the data plane encapsulations and the control plane mechanisms for the virtual network instantiation. And for the management plane, basically the young data models can be used. Most of the existing young models defined in the IETF can be reused with some possible enhancement for the creation, modification, monitoring, and the deletion of this kind of virtual networks. This document also has some descriptions about the OEM resiliency and also telemetry, etc. Okay, this picture shows the overall architecture for the enhanced VPN or VPN Plus. This has been shown several times in the working group, so we will not give details. We can see that it gives a layered architecture, including the enhanced data plane and the virtual network layer, also the controller management for the centralized management of this virtual networks and the physical network. Here are the updates after last presentation in IETF 104. First is there are some definitions polished in this version. First, we have some description about the role of the transport network in the 5G network slicing, because the network slicing is considered as the major motivation and the current use case for this enhanced VPN. The end-to-end network slice of 5G consists of the three major types of network segments, including the radio network and the transport network and the core network. For in the end-to-end network slice, transport network provides the required connectivity with the and within and between the RAN and the CN or core network parts of a transport of an end-to-end slice, and provide a specific performance commitment. And this document also refines definition of the transport network slice, which is a transport network slice is a virtual or logical network with a particular network topology and a set of shared or dedicated network resources. and it can be used to provide the network slice consumer with the required connectivity and the appropriate isolations and the specific SLA. Another update is about the data plane. In this version, we reduce and refine the descriptions about the segment routing, because segment routing is considered as just one candidate technology for this virtual network instantiation, and more details about this technology are described in the spring draft. So in this framework, we just give some analysis about the gaps in the current segment routing and provide a direction for the possible enhancement. We think currently the segment routing is mainly used to SIDs as the topological instructions, and the ISRT path steering is at the link granularity. While for some enhanced characteristics required by some 5G applications, we may need to introduce fine granular packet steering in the segment routing with possible extensions. But these extensions are not described in this framework draft. Okay, the management plane in this draft, we clarify the relationship of the existing data models and their applicability to the enhanced VPN management. We also try to map the management architecture in the 3GPP network slicing to the ACTN architecture we defined and developed in IETF. Basically, we can see the interface, a northbound interface between the network slice management function and the network slice subnet management function for the transport network can use the existing data models defined in Ts, such as the VN model for the service provisioning, for the service delivery, and we can also use MDSC to provision the T tunnels or topologies to the next layer controller like PNC. For the service monitoring, we also have this kind of models for the VN telemetry or for the tunnel telemetry. Basically, there are two options listed here. One is we can use VM to directly describe the service requirement. Another case, we can use the layer 3 or layer 2 SM models to use as the service delivery model to the customer, and we can use a service mapping to map the layer 3 or layer 2 SM models to the VM model and further to the tunnel models or topology models. Some other updates, including the descriptions about the telemetry and how we can consider how to introduce telemetry to help the information collection for specific VPN Plus tenants. And we also improved the scalability consideration section and the security consideration sections. There are also some other editorial changes in this version. Okay, this page is, we want to talk about the relationship with the network slice design team, because we think we have the same goal to define and transport network slice and the architecture in IETF, and we work together as a member of the design team to provide the definitions and the architecture, and we want to we also finalize to define the scope of the design team. Based on recent discussion, we think that the design team has reached some agreement, a rough agreement on the transport slice definition. And this kind of agreement.
We have a presentation from the design team, so it's really not appropriate for you to be.
Okay. Just we want to propose some suggestions about whether the design team can coordinate with
I suggest you bring the questions related to the design team when the design team is presenting.
Okay. So in the next steps, we will continue to solve the comments received on this document. We work together with the design team to polish the definition architecture, hopefully in this document, and we will try to make the document ready for last call in the following weeks or months. Okay. That's all for this presentation.
Thank you. Just a question. This is Dave Senecro from Ericsson. So as I read the introduction to the draft, it talks about enhanced VPN and trying to work deterministic transport methods into the existing VPN mechanisms that we've got. Yet, if I look at the presentation you just made, you're kind of pitching the draft as an architecture for network slicing and how transport interacts with network slicing? Which is it? Is it a method of providing deterministic transport to VPNs, or is this the new architecture for network slicing?
Yeah, I think we explained in the beginning that we think it's a framework for VPN Plus, and one of the use case of it is network slicing in 5G. We can also use it in other scenarios.
But it's one use case of enhanced VPN. It is not the use case for enhanced VPN, correct?
Yeah, I think the presentation went a little afield from the document. You know, we have a working group document that's focused on one thing, and it's focused on a particular solution, and it sort of drifted from that document into the whole slicing discussion, and I think that's confused things.
Okay.
You know,
I would like
if
a
you
clarification.
can focus, when talking about a working group document, keep the focus on the working group document, not go beyond the document.
Okay.
Adrian Farrell. The document's quite clear about the slicing pieces.
Sure.
I don't think what G was talking about in terms of slicing deviated from the document at all. I mean, I'm not quite sure where your statement came from, Lou.
When we got to the end, it was pitching all about slicing and the design team. That's not appropriate for the working group document. The document isn't about the design team. It's about the document.
Okay, so
the scope of the
there was a slide out of context.
It went
fine,
out of
but
it
the
went
document,
afield from the document.
Don't agree with the comment either. The document makes it clear that it can be used for slicing, but it does not pitch the document does not say it's an architecture for network slicing.
It's an architecture for the
which is what
enhanced
this is
VPN.
being, which is basically what this
We
is
say it's
portraying.
a VPN Plus architecture.
So I would like clarification as to what the intent of the document is. Is it meant to be an architecture for network slicing, or is it meant to be an enhancement to VPNs to add deterministic transport to VPN?
The document is clear, and what was accepted by the working group is that we have an enhanced capability for VPN, and one of the use cases, not the only use case, but one of the use cases is slicing.
Okay, thank you.
That's how I read that's how I read the document. That's how I read the document.
and I think I would agree. It's not an architecture for network slicing. I'm not sure anybody's done that. I'm not sure anybody's defined network slicing even. But in terms of transport, it is a way of providing network slicing. A way.
Also, my expectation was that the design team will come up with the definitions and you would just reference it, as opposed to you defining it in this document.
We can, I think for the definition, we can work together to make it reflect the required attributes and the capability for the transport network, because we have the same purpose to use this technologies in IETF to provide this, to meet these use cases like network slicing. Right.
So I think the suggestion is be a little schizophrenic. This document is focused on enhanced VPN.
Yes.
Focus the discussion here on enhanced VPN. When you are participating in the design team, you participate in the design team and try to figure out how enhanced VPN can be used with it. But when you're talking about this document, this working group document, limit the scope of the discussion to what's in the document. And certainly the fact that it's a use case, one of the use cases is slicing, that's fine, but it's not the only use case, and it's not the same as the slicing design team. Here you have a working group document, focus on the working group document.
Okay, but we have the same use case.
Yeah, I feel like I'm getting my exercise jumping back and forth to the mic, but this is Dave Sennekrop again. One of my comments on the draft, insofar as I've gone through the draft, it is a little bit focused on network, too focused, in my opinion, on network slicing. This would be a good mechanism possibly for generic support of deterministic transport for VPNs. but it basically colors everything as the application being network slicing. I think it's good to emphasize that that's one use case, not the be all end all for the document.
Sure, and I certainly have seen others talk about a enhanced VPN for DetNet as a use case, and it should fit in here too, possibly. Okay.
Next is. Okay, so this one is a new draft, which is about the control plane considerations for the enhanced VPN or VPN Plus. First is just to describe the enhanced VPN framework in the previous draft, which is a layered architecture with candidate technologies in the data plane, control plane, and the management plane. And the use cases just mentioned, network slicing and other generic scenarios. For this document, it gives some analysis about the requirements, functions, and some considerations about the control plane for the VPN Plus, so that it can be used to guide the design of the control plane mechanisms and the extensions in the other working groups. So some requirements on the control plane. First is we need to consider to support the isolation. The first is the data plane isolation. Although the data plane isolation is directly provided with the mechanism in the underlay data plane, the control plane needs to help to collect and distribute the necessary information needed for the both soft and hard isolation to the control plane, also to the controllers. And the second part of the isolation is about the isolation of the control plane itself. In this control plane, we already have different mechanisms which can provide you different levels of isolations, but with different overheads. For example, we can use the multi-topology-based technology to give you isolated topology, or the RIBs. The multi-instance can give you further isolation with more overhead. And logical system is another case which give you even further isolation in the control plane. So for the second requirement is to support the attributes of we use the transport network slice, because this is a major case. For the transport network slice, we think there are two major types of attributes which should be distributed in the control plane. The first is the topology attributes of the slice and the resource information associated with the slice. The third point is we need to consider how to support the different numbers of network slices required in the different phases and the scenarios we will face in the future for the deployment of the transport network slice. This is mainly relevant to the scalability considerations we will discuss more detail in the following slides. And for the control plane, functions, we think it should be a hybrid of the distributed control and the centralized control plane. So for the distributed control plane, there are two layers, typically the overlay and underlay. For the overlay, it's just need to work on the distribution of the routing information of the VPN Plus tenants. This is the traditional functionality we need to have in the overlay. While for the underlay, the purpose, the functionality is to advertise the customized topology and the associated resources of each network slice, and it also need to do the customized computation to generate the routing and the forwarding entries for each independent slice. And for the centralized control plane, we think the functionality is to collect the topology and the resource attributes of each network slice, and to provide a global computation and optimization of the T paths within each network slice. Here are some considerations about the scalability, because we think in the deployment we will have different scenarios which require different number of network slices or EVPN plus. So this kind of number can range from tens to hundreds or to thousands or even more. So we need to consider this control plane scalability from the beginning in the design to make it a solution scalable. So for the scalability of the distributed control plane, we need to consider several aspects, such as the number of the protocol instances we need to maintain on the nodes, and the number of control sessions for each node. Another thing is the number of routes to be advertised in the network. This is also need to be considered because we have multiple virtual networks, how we can control this kind of number of routes. And the attributes for each route, we also need to consider the scalability in this case. And another thing is for the computation. Usually we need to do the routing computation like SPF on the devices. So this number of the SPF computations is also another case we need to consider for the control plane scalability. So in order to meet the different levels of scalability requirement, we need to consider some optimizations for the design in the control plane. So here are some suggestions on the control plane optimizations. The first is we need to reduce the number of control sessions so that we can first control this flooding and to reduce the operational overhead for the control plane. This is can be done with a shared control plane to distribute the information of multiple network slices. In this case, we will need to have some identifiers in the control plane to distinguish the informations of different slices. The second point is we can also decouple the attributes of different type of attributes we need to advertise and process in the control plane. One example is we can decouple the topology attributes and the resource attributes in the control plane. And in this case, if we have several slices with the same topology, we can run SPF just once, and the results can be shared among all these slices. So we can control the total amount of the computation overhead for this SPF computation. Another suggestion here is because we have a hybrid control based on the centralized controller and the distributed control plane, we can divide the load between the centralized and distributed control planes so that we don't need to rely on one of them to do all these works, and we can reduce the load on each of them. Okay, for this draft, we would like to solicit comments and feedbacks, and based on these considerations, we can consider to work together or coordinate the protocol designs.
All right. So just in queue is me, then Daniele, and then Jeff. Just so you know, just wait a moment. So the first question, the question I have is on the title. You said VPN plus, but the content seemed purely about slicing. So is this a slicing control plane document, or is it something about VPN plus?
Yeah, it's VPN plus, and it can.
VPN plus already has a control plane section that is very different than this one.
I think that's in the framework, you mean?
In the previous document, there's a control plane section that is consistent with VPN approaches. This seems very focused on slicing and talks about things which are a bit orthogonal to VPN plus. So just to clarify, what's the objective of this document?
I think actually both drafts, they are consistent on the control plane, but this one is provide more details about the considerations which we need to put into consideration on the design for the control plane. That one just describes the functionalities in briefly in that one, because the control plane is just one section in the framework, but here we want to just put more details so that it can be useful for the protocol design.
Okay.
Yeah.
Daniele? Remote first.
Thanks.
Jeff?
Can you hear me?
Yes, you're a little low.
It works, great. Hi, everyone.
Hi.
I miss all of you. So I would like to echo Lou's comments and the one that Dave made before. Please try to keep focus on the topic, not to overlap with the work that is being done by other teams, other documents, etc. This document makes me feel like there is some confusion also on the scope of the document that you have previously presented. So I would like to reinforce the statement that this should be focusing on VPN plus, not just deterministic traffic, in my opinion, should be covered, but also the possibility to deliver VPN traffic with given SLAs, given KPIs, not just in a deterministic environment, but more generically from layer 0 to layer 3 environment. Thanks.
All right, thank you.
Questions.
Okay, so your audio was a little low. Maybe restate it, and I'll I'll repeat it. If you could just type it in, I'll repeat it. Jeff.
So, besides what Lou said, when you call for centralized control plane function, it really looks like management plane. Actually, a lot to me. And I read all the kind of accompanying documents. You should really be looking into kind of avoiding further pollution, BGP less some other stuff into management plane function. Because a lot of this is really management plane, has nothing to do with control plane, neither with distribution across network. It's kind of peer-to-peer situation between node in question and some business logic on top. So maybe you just extend the name to management and control plane consideration, and you separate this.
Okay, you mean that some of the protocols can be considered as management plane functions for the centralized controller? Yeah, I think this kind of boundary has become blurred recently. Yeah.
I mean, we keep putting stuff in BGP, and it doesn't do any good.
Hi, I'm Jen from Siena, and I was reading this VPN Plus.
Can you lean into Mike?
I was, my understanding of the VPN Plus framework RFC was that it is not intended for a large scale of instance in a network, a VPN Plus instance. Although when you explained here, you were saying that the scale would be much higher in hundreds, or although the draft RFC says the opposite. So how do I interpret like these two things?
Can you repeat briefly your question? Thank you.
Okay, the draft RFC of VPN Plus framework, when I read it, it says that it is not intended for a large scale of VPN Plus instance in a network. Although when you presented here, you are talking about a larger scale of VPN Plus instance.
Yeah.
So.
Yeah, because in that one, we actually talk about the comparison between enhanced VPN and the traditional VPN instances. The number of the enhanced VPN is considered much smaller than that case. But still, even for the enhanced VPN itself, it has different phases and scenarios in the deployment. We're considering we need to meet this kind of scalability for different phases in the design of the protocols for the enhanced VPN itself.
Yeah. Okay. Thanks.
Adrian Farrell. I agree with Jeff that the line between control and management has become very muddy, and we need to sort it out. And I agree with Lou that any other work on control plane needs to be consistent with the framework. There is a section both on management and control plane in the framework, and it's about half a page each. And this is a 10-page first draft. And I'm wondering whether we should be pulling more material into the framework to describe control plane or having it in a separate place. Thoughts from chairs?
I thought one of the earlier versions of the Enhanced VPN Plus document could be pre-adoption. It had a control plane considerations section. I thought it got culled for a good reason, because this is it seems like you took most of that text and put this in this new document. I wouldn't be comfortable bringing it back into the base document.
So we should be looking to get the consistency, but keep the detail out of the framework.
I'm not sure that's what he just said. Is that what I think he said the text isn't comfortable. I'm not comfortable with the text either, but for a different reason. For a different reason. I would like to understand what the control plane is for VPN Plus without seeing the word slice, because I want to understand VPN Plus. I don't want to understand slicing. I don't want a slicing design team. I don't want, there's already other folks doing slicing. If VPN Plus is something where slicing is just one use case, define it without that word. Also, be consistent with our VPN technologies and what we normally do. MRT or MTRs, but never used it for a VPN technology in the IETF. So why is it in here?
I hear you, but I'm not getting an answer to my question, which was, is it right that the detail of the control plane for VPN Plus and the management plane should be in a separate document from the framework?
As you've seen me before say, I'm more worried about the text and what document it's in. I'm a fan of less documents where appropriate, but sometimes you need to split things up. So if we were talking about text that made sense to me, I might have a different opinion. Right now, I completely agree with Pavan. I can see combining this in the other document because it doesn't make any sense to me. Where do we do VPNs using multi-topology routing? In the IETF. Where? That's what this document says to do.
Yes. Just one comment for this discussion. Actually, my name is Uma from FutureWay. I think a lot of clarity will come if you separate overlay and underlay. There is a control plane for underlay. Maybe that's what you're talking about. If you separate that, that's make it much more easier to discuss. Because for establishing the VPN Plus, you may need a control plane. For underlay paths or TE topologies or whatever it is, there is a separate control plane, right? So these two need to be separated. For the discussion, that will help for some of the questions you are asking, Chair is asking.
Yes, I think you are right that there are overlay and underlay for the VPN service. And actually for the enhanced VPN, what we are considering is the integration of the overlay and underlay, because previously people think they are separate. You can have separate management and provisioning for each layer, but now we are thinking for some services, you need to consider the mapping and the integration to give the performance and the characteristic required by some services. So this is we can clarify that part in the document.
Yeah, maybe it's just my personal perspective, and I'm not saying this, as a contributor to this group, my expectation that something called VPN Plus would build on our VPN techniques and technologies.
Yeah,
not throw them all out and come up with something which doesn't exist in the IETF. It would be plus, not next generation. I have one question, one comment that I'll channel from Daniele. Deterministic VPN makes me think of packets delivered in order, not a single packet dropper. A VPN with constraints is a VPN that might have upper bound limits in terms of delay or have a given amount of reserved bandwidth in the network. He had an earlier comment also, is the confusion in this document makes me feel there's the same confusion VPN plus framework in terms of scope. Please make sure this is not another attempt to define network slicing, but focus on VPN plus, and if possible, not just deterministic VPNs. But VPNs that can deliver traffic with other KPIs and SLAs.
Yeah, for the terminologies, we can consider to make them consistent in the documents. And yeah.
All right. So now we actually are going to move on to the slicing design team. So that was VPN Plus is a working group document. The control plane for enhanced VPN is an individual document, and now we're going to hear from Jari.
Okay, my name is Jari Arkko. I'm here to talk about network slicing design team status. We're basically just starting up, so don't expect a fully blown architecture and everything, but we have scoped out our task a little bit. So I'm going to talk about that. The design team setup, basically we were tasked by the chairs to develop a framework for providing a network slicing using IETF technologies such as MPLS to use to create specific isolated and managed network instances. And as you know, this is a broad and diffuse topic, slicing, and many marketing words are used. So our key challenge is actually trying to focus on the IETF and TIAS relevant part of this broader topic. And even the term slicing is a little bit dangerous because it tends to be used very easily and associated with compatibility with 5G and many great things, but at the same time some of the terms aren't sort of fully defined and used in multiple different ways. So I think the approach that we are trying to take is have clear definitions. We're not there yet, don't expect that, but have clear definitions of exactly what we're doing, and not focus so much on what things are called, but actually what they are doing. We have 16 members initially, although other people have also joined our calls, for instance. We have open calls, you can join them. We have mailing list archives that are open, and any results that we might get will be brought immediately to the working group for your consideration and debate. The design team timeline and status, this was basically specified by the chairs in the original announcement. This IETF, we're supposed to look at what our plans are, what scope we believe our work should have. We've also provided some individual contributions at this, like some draft submissions have been made, and there's some discussion about things, and you'll see some things on the slides later. But we're not there yet in terms of having a sort of converged, agreed definition, for instance, or any of the other technology components. At the next IETF, the idea is that we would have an initial framework draft from the design team for your consideration, and then the one after that, a stable draft. So what is the scope of the design team, and what is our plan? So this is basically about for context, at the IETF, we've had a few meetings where we discussed network slicing, and it was more or less all over the place, everything under the sun, and it was very difficult to focus. So we're trying to take back from that, or take a lesson from that, and go back to basics, and just explain how to use existing IETF transport technologies and TE technologies. What we'll need is definitions. What are these things that we are trying to create? We'll need a framework that describes the overall setup, the system, what interfaces there are and components and so on. We'll need some set of requirements that we understand what are we trying to do. And then we actually want to use existing IETF technology for the necessary components and interfaces that we identified in the previous step. Of course, maybe we have to extend something, that's a possibility, but the desire is to, at least initially, we will produce, say things that, we can use this in this manner rather than build an entire new thing. And we're not quite there yet. We haven't done this analysis. So the results to be seen, but that's the goal. And sort of at this point, the overall view is that we'll need some kind of northbound interface where some other entity can request these connections or slices, and they'll specify some set of characteristics that they'll want, this bandwidth and latency and whatnot. We'll need a way to map that to particular IETF technology, so that request at the high abstract level needs to be mapped to, this is how we do it in MPLS. And then we have obviously the underlying IETF technology that we can use as a component here. We also would like to provide some use cases that we can sort of use as examples, and also verify that we have sort of some sense complete support for some particular case. And our plan is basically just go through these things that you see on the slide and provide documents on each topic one by one. We did draw sort of a very simple picture yesterday about what's the model that we have in our minds, and there's this northbound interface that perhaps exists already in the working group existing documents, or maybe needs to be extended somewhat, but there's an interface for requesting network slices or connections. And then there's some kind of controller functionality and implementation, a piece of software that maps those requests into existing technology in the underlying network and sets up, for instance, a virtual network of some sort. In this particular picture, what we have is 3 different connections or slices that are entirely separate from each other and also using different technologies in this case. There's obviously other cases. This is just one example in the picture. Then at the top of the picture, you'll see something else, which is a customer of some sort, or higher level system that makes these requests. And that's quite potentially something that's outside the scope of us at the IETF, or at least outside this working group. One example of this high level system might be 5G, and they would not be able to use, our results for everything that they need for slicing, but they might use it for a particular piece of their functionality. So they might also end up using other parts than the IETF technologies. And that was sort of the positive way to define that this is what we want to do, but there's also a negative definition of, this is what we don't want to do. This is not an overall definition of all possible ideas under virtualization. This is, it's not our role at the IETF to define 5G slicing. They might use our results someday, but it's not our role to define that particular system or any other system beyond our own. We're not taking, therefore, the role of any other SDOs, but rather work together and provide components for others. It's also not about picking a particular single implementation technology, like, we will only use, this technology to implement these slices. It might be, in the best case, just a better definition and explanation of existing technology, although it's, of course, possible that some extensions are needed. We have debated definitions for what are we doing quite a bit. We're not quite there yet. So there's some, many open areas here, but I think it's useful for you guys to understand where we roughly are thinking. So we could call this thing that we're trying to create in this architecture a transport slice, or simply a connection. It is an abstract network topology connecting a number of endpoints with an expected network service specified as service level objectives. And a few notes here, and this is, maybe similar to some other things that we've done in the past that might actually be great. We might be able to use those results directly. We're trying to be generic in the sense of this is not just point-to-point connections, but could also be point-to-multipoint and so on. It could be hierarchical, multiple levels specified in some fashion. The characteristics that we're talking about here are typically like bandwidth or latency, but there could also be other things like, I really want to physically separate paths so that if somebody cuts the fiber, then we're not down totally. We wanted to specify this as a slice connecting to only endpoints which can be then basically whatever else there might be. And if you need to stitch different connections or slices together, you can do this through an endpoint. We only cover transport, so this is about bit pipes. So if you need firewall functionality, you need a 5G node for some purpose and so on. These are not part of our model, but transport could connect potentially these entities together. And indeed, this is still work going on. I also wanted to briefly show a couple of other pictures. You may have seen some of these before in other contexts, possibly even during this session already. It is just to show that, like, the abstract thing that we're trying to talk about, how that might map to some real world pictures, or at least some people's perspectives of the real world situation. So this particular picture shows like this 5G example where you might have transport network slice part of things, which is what we would be focusing on. But there might also be other things. There might be like a core network slice functionality that we here at the IETF know nothing about. There might be some radio network slicing aspects that we don't know anything about, but we would provide the plumbing between some of these components. Sort of another way of looking at this is that in 5G you have this concept of end-to-end network slice, and this picture tries to show how what's our role in this, and the end-to-end network slice is a concept that is different to what we're trying to do, and it's defined by somebody else, and it includes many other things, but our transport slices might be part of this bigger whole. In the presentation, there's a bunch of pointers for further reading. The announcement, we have list archive. We have notes from all of our calls, except the ones we held this week. Those notes are not there yet. And some pointers to documents that one could look at. These are, in some cases, working group accepted documents for some other topic. In other cases, they are individual documents or with some possible collaboration with several people. None of it is agreed as a component. In general, our approach is that we had previously discussion that, but are these documents for slicing or for some other purpose? And my personal perspective, at least, is that define the great service, whatever you're working on, and make it clear what it is. And then that could be something that we could use as part of this, that, hey, if you need this, then go do that. And we don't do any extra work here in our team. So I think that's about it. And I don't know if the chairs want to add something, or other team members, or, and I guess the purpose of this presentation is for us to just to listen to you. If you have any thoughts on, this doesn't make any sense, please change direction, or make change, and, or, add this, or take away that, or point us to other things that people have done in the past that would be useful for us. We stop reinventing the wheel and so on. So that's it.
Hi, Himanshu from Siena. I have a clarification question. So are you covering the soft slices or hard slices, or independent of that? And hard slicing meaning with the Ethernet channels or lambdas and all that stuff. So, or, I mean, whether it's independent of all that, and if it's not, then you are determining whether this particular requirement or SLO requires hard slice. This one requires affinity diversity and stuff like that.
So we had quite a bit of discussion on that, and maybe Jeff can also pitch in, but the basic idea is that we're trying to separate between requirements, and I'm telling you, the slice system, that this is my requirement, and then you may implement that requirement in particular different ways. And obviously you can have requirements that also talk about like how well isolated some things are. But we're trying to cover all of that under this SLO term, that you have bandwidth requirements, isolation requirements, that no fiber cut can cause you damage, no single fiber cut can cause you damage, and so on.
The idea is to build a set of APIs or northbound interface that's expressive enough for you to be able to express any type of constraint that would be then realized by underlying infrastructure.
Robin from Huawei. In fact, this is take the role of the liaison work in IB. So because we know that this has much relation with 3GPP, to be honest, they also talk about the network slicing. So I think is there some consideration on the liaison or some way, maybe some of the representative in this team, or what's your plan on this one?
So actually, I'm the 2GPP liaison from IAB, and this technology is to work on slices. It's not to liaise with 2GPP. It could be network slice, 5G network slice, enterprise network slice. It's a network slice that provides infrastructure to build it. We don't need to engage with any other SDO in particular in order to do this work. There are many SDOs that do this, IETF, some others. So it's not specific to 3GPP.
So that's exactly right. And to sort of emphasize that even a little bit more, like we're trying to provide a useful function. Once we have defined a useful function, then it may be more relevant to talk to others. We're not redefining what 5G or 3GPP guys are doing with slicing. They might use our results, but before we have any results, then there isn't much to point to. Of course, some of those people, and they also interact here at the IETF, might come with some requirements.
Okay.
Yi Ling from Huawei. When you're defining the transport slice, my suggestion is if we can do some description about the relationship and the differences between transport slice and those about VPN, enhanced VPN, and virtual network, and network abstraction, etc. That would be much clearer for the industry. Yeah, I know it's
any technology you've mentioned could be used to build a slice or particular part of slice or particular level of the slice. They don't operate at the same level. They're technologies that could be used.
Okay.
My name is Reza from Nokia. I'm part of the design team. Maybe I just give a clarification about a few questions that I heard. There are concept of the transfer slice, concept and implementation. All this discussion that we have here, for example, VPN plus, hard slice, soft slice, all these are implementation of a transfer slice. For example, you want to connect two nodes together. At the end of the day, it doesn't, from the customer perspective, it doesn't really matter how it is implemented in networks as long as the SLA or SLO are satisfied. You want to connect from the customer, they just ask connectivity. They don't ask you to connect something and by the way use VPN or use the segment routing RSVP or hard slice or soft slice. They just give you a requirement. I need this transport, this connectivity to be fully secure. When I receive it as an operator, I translate that to be hard slice, meaning I have to have a specific node for that implementation. Maybe from other operator, that means something else. So all these are related to implementation and the mapping, and this is one of the items that we definitely we are going to discuss it and how we are doing it, and we go through different use cases, different examples, different technology, and we give some recommendation that if you want to implement it this way, so this is basically the best practice that you can do. But this is basically the whole idea of the implementation, which is very important, but at the same time, they are completely independent from the definition that we have. We have to make them separate. Otherwise, if we mix them together, we come up with something that is not really manageable. Thanks.
Okay. Thank you very much. Obviously, there's a lot of interest in this topic. Really appreciate you and the design team's energy in this area. Shufang? Also, we went a little long in the previous, so the remaining 10-minute slots are 7 minutes long, please.
Try to be fast.
Good afternoon. I'm Shufang Liu. So here the presentation is about the transport network slicing. This is part of the network slicing design team effort, but This draft is an individual draft, not a design team draft. So not agreed with by everyone in the design team yet. So even the terminology here, I put here the transport network slice will be aligned to whatever the consensus we reached. Could be a transport slice later on. And the idea and also the tactic here is to reuse as much as possible the existing IETF work and especially TE's work. So currently we already have the network topology models, a whole bunch of them. We have base topology model, RC 8345, and based on that, we derived a whole bunch of different models, OTN, L2, L3, TE topology. So how do we deal with the slicing? And we add another augmentation at the same level. So the way we do that, we augment the base RC 3345 base topology model so that we have independent separate type. By doing that, and also using the multiple inheritance of the base topology model feature, we can make the slice model either without TE or with TE. So here, if we have the slice type and also TE type, then we got a transport slice with TE. And we can even have more types here. So we have layer 3, we have packet extensions, then we got layer 3 TE topology with slicing, and also we may have even have a service function aware topology on there. And we also have ACTN, a set of models here. And many of those models are topology-based models. So they are based on the base topology model, RC3345. So once we augment the base model, here effectively we augment the ACTN model, making it slicing capable. And we have a few examples. I put 2 simple examples here to show how do we use this. Here we have 2 customers, blue and red. They each one of them wants a slice. So the service provider side, they have this 4-node resources topologies, R1, R2, R3, and R4. They are all physical routers. So once the provider receives the request to have a slice for red and a slice for blue, the provider here, based on the requirement, here will be this is a hard isolation, like Himanshu mentioned. So here, because you need to have a hard separation, then the way the provider did is doing some virtualization, split the R1 into 2 smaller virtual node, virtual routers, and each one of them take a piece of memory and take one dedicated physical port. Same thing to the VR3 and VR4. So by doing that, the blue piece on the top will form a slice of the network, which will be customized topology provided to the blue. And similarly, we got another piece for red. They are all physically isolated. Then in another case, if the request coming from the customer is like a soft isolation, it's virtual resources isolation. In that case, the provider here, they have like 4-node resources topology here. So R1, R2, R3, R4, and R5. The way the provider to achieve this is to build some TE tunnel in their native topology. And on top of that, we'll have a overlay, which is in the middle of the picture. Then we have a virtual network there, and take one piece for blue, another piece for red. So we got two slices there. The way the relationship here, right? So we based on the gray arrow here. So we show which one is coming from where. So we can drill down into each level and find out which particular hardware is used to support which particular node to the client side.
2 minutes.
2 minutes. Okay, here's the model. And this is an augmentation. We see how much we added in. And we have the example JSON encoding. So the base native topology, nothing with the slice, the network type is empty. And then we have the network type required as a slice. And we see at the node level, we need to have the physical separation. And the topology level, we need the physical separation also. The link level is also physical network isolation. And the node is memory isolation. Once we have that, another possible for that TE case, the difference is here, we have all the virtual resource isolation, all the different kind of, we have TE overlay in the model. So this will achieve the soft isolation and provide to the client. So in the draft, we have a full JSON encoding for the two examples. I'm done. Do you have time for question?
One question while the next speaker is coming up.
Reza from Nokia. Just can you go to 7 and 8? Again, if some clarification, I guess that we need more discussion on this, either 7 or 8. You know, if we superimpose this one to the whatever Jerry mentioned before, so what happened to slide 7?
Right, as I said, you can talk while the next speaker is coming up.
Okay, we can talk. But
yeah, we talk
just make sure that, you know, everything that we put here is aligned with those terminology. It uses network slice. So we need to
have a lot of
clarify that.
too.
We can discuss that. But just
all right, thank you. I'm sorry, we're definitely tight. So these are all fairly. I think they're all 0.0 or no. There's one that's not, but these are all pretty new documents. So discussion should take place on the list, and we'll get more time the more discussion you get. 7 minutes, please. Just hold it.
Hi, good afternoon. I'm Joanna from Huawei. It's the second time to present ICANN for traffic engineering. The latest draft and the co-author from China Telecom and LG Plus. Okay, the current network have the partial congestion. For example, multi-paths between two edge nodes. Some paths is heavily loading, but some paths is lightly loading. So the average bandwidth utilization of the most operators' network is around 30%. It's a low network throughput. The network congestion leads more traffic loads and more delay that have the seriously impact on service experience. So how to avoid it? There are two granularity of traffic adjustment. Look at the path level scenario. The SD controller will optimize the traffic information in order to bypass the congested link. In plus flow level, the path information is kept. The ingress node only optimize the mapping between paths and flows. In series, the granularity is finer. and the network utilization is better, and less impact on the existing current network. This data from China Telecom, Guangdong Institute, and Huawei innovation team. The PAN's traffic is monitored in tunnel entrance from mobile backhaul network. Look, the peak to average bandwidth ratio. It's about 3 or 6. What causes this problem? There is 2 typical services. One is interactive business, such as Taobao in China from Alibaba, which is the online shopping application. The peak to average ratio is about 86. With the continuous introduction of new interactive services, the peak to average ratio of the network traffic will become more and more serious. The ICANN architecture is proposed. This architecture can be divided 2 aspects to understand. On the one hand, it's the centralized mode and the distributed mode hybrid. SD controller is responsible for optimizing path information to bypass the congested link. Ingress node and egress node are responsible for optimize the mapping between paths and flows. On the other hand, the path quality monitoring and flow recognition standardized mapping between flow and mass are all running in data plane in order to do with the microburst. So this architecture achieves millisecond closed loop reaction. Path quality assessment is a key technology to ICANN. The method uses the periodic measurement. For example, ingress router will insert the measurement message to the traffic, and the ingress router will feedback the measurement result to the ingress router in the same interview. So it's available in multi-path scenario. Okay. Path quality assessment is also important. The path congestion metric is from receiving rate and the transmission rate. The method also considers the flow pathing switching. We give the comparison between before switching and after switching. Okay, this method considers the packet loss assurance in flow path switching. Okay, the prototype only for data plane. Using ICANN, we proved the network throughput by around 30%. We believe that ICANN is a kind of traffic engineering architecture. Are you agree with me?
Why don't you finish and we'll talk?
Yeah. The path congestion metric and the quality assessment protocol are also required. Any question?
So from our standpoint, this seems like a load-based path steering approach. Yeah. Does that make sense to you?
Yeah.
So I believe that actually falls under the routing working group because there's like ECMP falls under their working group versus this working group. So he's the chair of that routing working group. So he can tell us whether you disagree or.
Yeah, absolutely. I would provide you with time to present, but in general, it feels like a déjà vu. Going back to déjà vu. going back to Fechen and Becken and similar technologies, I think very significantly you're mixing throughput with goodput, and they're not the same thing. And congestion mechanisms use TCP, something built in like quick influences your goodput much more than quality of the path. Because otherwise it's just pure theoretical exercise, and I think I've seen this at least 15 times in my life. Please consider the characteristic of the flow itself, including congestion algorithms that are used, and then it will become much more interesting discussion. But in general, I would agree routing working group is the right place to discuss it.
Thank you. Thank you very much.
Thank you. So we need to move on to the next E. Thank you. So 7 minutes.
Thank you, Chess. I'm Lin Yi, to present the ICP extension to support the proactive protection. And this is the new draft. And the background is that we know that there is some always some indications before a physical failure happens in the network. And if we can catch up with this kind of event, we can do a prediction before the real failure happens. And one of the typical examples is that we know that in the optical transport network, most of the failure is because of fiber cut. And if we look at the fiber is quite sensitive to the pressures or stretch. And say if we have a digger coming nearby and dig in the ground, the fiber will some of the parameters of the fiber will change a lot. So if we can catch up with this change, we can do the prediction when the fiber will be cut off. So the main idea of this job is to, if we can have this kind of failure prediction function, then we can create a protection path after receive the prediction event and before the real the real failure happens. So we made the extension to the ICVPT protocols to support these kind of functions. And because the prediction is quite physical technology related, but the protocol extension is really generic, so we are not sure to push in C-camp or TIS. So to be safe, we present in both working group and ask the chairs to help us to decide.
Yeah, this would belong in TIS.
Okay, thank you. And this is the overview of the predict failure and proactive protection. And on T1, say for example, the node C predict that the fiber between C and D will be cut off, and then the node C will send a notification message to node A, and then node A can create a protection path from A to D. And in the at T4, when the real failure happens between C and D, then the node A can switch to the protection path. And at T5, and if the predict failure at last didn't happen, and then at T7, if we can, if we judge that it's safe enough, we can tear down the protection path.
It might be worth just jumping to where the current protection mechanisms aren't good enough.
Yeah.
Because there's current RSVP mechanisms that allow you to add and remove protection paths already.
Yeah. Okay. So here the reason why we introduced 2 bits in the protection object is to indicate the intermediate node to start a prediction function. Okay. So the protocol extension is quite simple. We add these 2 bits and which is used to indicate the to ask the middle node to start the protection function. The prediction function. And okay, this is for the segment protection. Is very similar. And another extension is to the notify message. We may need a new sub-error code to notify the source node about the prediction failure event. So, and also we may indicate the time of the prediction. And if the failure did not happen until T6, then we can consider that it's safe enough to tear down the protection path to save the resource. That's the extension. And next step, I think Charles have answered the question. We can continue this work in the TIS, not C-Camp. And because it's a new draft, so we are encourage the audience to have comments and for us. Thank you.
Just interrupt. Number of observation. RCP seems to be the most unsuitable protocol for what you're trying to do. Self-state protocol and prediction states prediction might never come true, right? So you're creating state across your whole network to trying to configure something that might never happen. Why don't you look into creating local state on PLR? So not that is attached directly to failure, and at least you reduce the blast radius. So if something happens or you predict something's going to happen, PLR might create some state and reroute the traffic. However, in your case, you're creating state across whole network for something that might or should never happen, right? RSVP doesn't seem like a very suitable vehicle to me.
So I'll interpret what you're saying as you should configure whether or not you're doing proactive protection, and if you need to signal that this protection event, then you add the new error message into the hello and you're done.
Yeah, so rather than trying to do path protection, do another link protection, for example. But again, not with RSVP.
If he wants to do RSVP protection, he needs to do it with RSVP, but he doesn't need to. He doesn't need to propagate the state everywhere. He could use config information to set whether you're running this mechanism and then just a new error code and hello to propagate the event.
It looks like return on investment doesn't justify it because amount of state is significant while probability might not be.
Yeah, Ito speaking, maybe the local protection may not be the best optimal protection path in optical networks. That's maybe sometimes it's useful to go back to the EDEN.
So we're out of time on this, but just a quick read of the room. How many think that this is an interesting topic to keep discussing? You know, it's a very early draft, obviously, but should we be hearing about it more, talking about it more? Yes, interested? So there's some, a reasonable number. How many are completely uninterested? Just Jeff. Okay, no, we got a couple. We have a couple, but you know, there was clearly some interest, so keep talking about it. But do listen to the comment about, you know, think about how much state do you really need to propagate through the network to make this work.
Okay, thank you.
Okay, Michael.
Six and a half minutes. Okay. Hi guys, this is Michael from Huawei, and today I want to introduce a young data model for service performance monitoring. Okay, as we know, the IETF defined a set of technologies to support the network performance monitoring and publish a set of RFC. But this mechanism cannot be used as a data source to measurement the VPN level or tunnel levels network performance. So to address these issues, we propose a document to define the young data module. It can help to do the network performance monitoring and VPN service monitoring, and also can help to use monitoring and management the network performance on the topology at higher layer or at the service topology between the VPN site. This draft is present in last year in Bangkok and in the BAS working group. There are many people are interested in this topic, and the working group has listed it in call for adoption queue. Here is some scenarios. If we want to do the real-time VPN service monitoring, we can measure per links First step, we can measurement per link network performance in underlayer network. And using this, the previous discussions, RPCs or another mechanisms, and then a report to the controller. And the controller can monitor per channel's performance, and the user can use subscribe notification method to drive this data, or just use only demand RPC, just like get RPC command to drive this module, to drive this data. If we can collect this data, so we can optimize the network based on this data. Here are two works need to do. The first is we need to define the model. We need to augment the network topology to provide this information at network level, and also need to provide this performance data in data level or in node level or link level. We also need to establish a relationship between the underlayer topology and the service layer topology. Okay. Here is to show how to mapping the service layer topology to the underlayer topology. Here is to show how the set one can map into the underlayer nodes. And here is a show how to retrieve this data. We can use subscribe notification to subscribe one service VPN's performance monitoring, and and it can periodic or on demand to receive the notification from the device. Or we can just use the get to retrieve this this data. Okay, we have one open issue in email discussion, and we talk about, we received some comments. We talk about should we add some like link type to indicate different channels technologies, and we print in, we bring it in the IETF email list, but didn't receive some feedback. But currently we add these types. Okay, so the way forward, we have received a good number support in best session, but chairs may not have decided it should be done in best. So we present this document in here because there are a few relevant draft progress in this working group. So we want to hear the chair's advice.
I think we need to talk to the best chairs and to the ADs, but this is something that's been going on in their working group. We can't just take it away from them. We have to go talk to them.
Okay, thank you.
All right, last up.
Hello, the final one. We're almost done. So this is Haomian from Huawei, and I'm presenting the Young Data model for client signal performance monitoring. This is a new draft, and we will present here and together in CCamp as well. So this is a new model, and the first question would always be why we need this model. And we have so far completed the configuration on the Ethernet service and the transport clients signals over the, let's say, the T tunnels, or more specifically GMPRS supporting tunnels. So the operator would need the kind of performance to be monitored per service or client signal configured on the CE part. So basically, this kind of performance monitoring is done by is configured by the controller and on the customer edge, and this is also to be kicked off between the controller and its upper hierarchies. So this is applicability and the scenario for the background. And then we have obviously multiple models talking about this, and this would also be related with some other functionalities like OAM, like alarm, and we also have it linked back to the configuration model as well. So basically, we are trying to follow up the reference to the existing RFCs, including the OAM and the alarm, and we also referring directly to the two modules has been specified to configure the two kind of service. And we've also noticed other performance monitoring related document. One is one for telemetry and KPI on the VN and tunnels. So this is the more network side rather than the service side. And the other is the previous topic in the agenda talking about the VPN stuff, and that is VPN service, which is different from these two. So we believe currently the boundary between the scope of the three works are clear so far. And what has been done? Okay, this is a capture of what the subset of the tree. So what has been done? So currently we only use the latency as an example for how to do the performance monitoring, and we can configure how you monitor the latency and how you read the latency from the using the models. And then we list we provide a table under our plane. The performance candidate performance parameters may include the bit error rate, packet loss, jitter, bandwidth, and so on and so forth. So it may be used from layer 0 to layer 2 networking, but some of them are more specific, more layer specific. So we present it here, and to make sure that we are doing the right thing, whether this thing is generic or technology specific. And from the perspective of the authors, we believe this is quite technology specific because we have layer specific performance, and would like to do it through a very specific configuration model as well. And to move forward, we need to make sure that we coordinate with other performance monitoring models and continue to make the parameters in the planned table to be incorporated into the model. So we would like to hear more feedbacks. That's all.
Any comments?
I'm Dieter Beller, Nokia. I suppose that this document is not specifying any new performance monitoring capabilities that have to be implemented in the device. I guess it's probably referring to existing mechanisms, and I think it would be good to have references to those standards or specifications that define those mechanisms. I understood that latency measurement is, for example, used as an example here, or as a first example. Also there, I think it would be good to add a reference how latency is determined.
Yeah, you're right. We are not creating new concept. We just try our best to reference to existing definition.
Yeah, so for me, I'm having trouble reconciling this slide with saying that this is all technology specific.
Okay.
Because this slide seems to imply to me that it's not technology specific, that there's a lot of commonality across technologies.
Mm-hmm.
Like, for example, everything you have under layer 2 is equally applicable to IP.
You mean the performance parameter itself, or we have not set up IP service in the grid models left-hand side?
Right, but you're asking, is this headed down the right direction of doing an approach that is technology specific?
Yeah, we have.
I'm saying you have an awful lot here that's not technology specific.
Oops. So the chairs would like to see the document move to this working group.
I'm saying a one that crosses all the technologies and allows the augmentation for specifics seems to make sense given that previous slide that you just showed.
Oops, this one?
Yeah.
Okay.
I mean, I think that's what this argues.
Yeah, so what would be the proper way?
To have a common mechanism and then add technology specific.
Oh, well, yeah, because currently we think, okay, the first one, the ACT and PM telemetry altimeter, this has been discussed to be a more generic format for how to do the generic PM function.
But I don't see augmentations in your document. I mean, I don't see that. I mean, unless I misread it.
Oh, okay.
I mean, I didn't spend a huge amount of time reading it, but I did read it. And as I read it, you're not augmenting a base model. You're defining new models, a new model that has all the parameters in it.
So let me understand. So what you want to say is a generic model talking about the performance monitor and this model augmenting the generic one.
I'm saying that seems to make sense.
Okay. Okay, we will continue working and come back.
I mean, yeah, and obviously there's others in the room who have can render their opinion as well.
Italo Busi from OE, I speak. I think if you are augmenting technology-specific modules, it's difficult to do that in a generic module. Maybe what we can have is some generic types, because maybe latency is the same for every technology. So we can have some generic types and import those types into this technology-specific augmentation. You
can at least should try. I mean, for example, IP and Ethernet, when I just saw that list there, would share an awful lot of things.
Yeah.
The other thing is that there is other Ethernet performance monitoring related work, notably in the IEEE, and we might be able to just leverage off of that, which of course ends up, countering my own argument, is that becomes technology specific.
Yeah,
I think a little more work needs to be done here to understand the different possibilities.
I also agree that the Ethernet is more complicated than the transparent one. So the transparent one would be rather clear. If you look into it, it's more, layer 0 and layer 1. But Ethernet has more.
So maybe you have two base models.
Okay.
But like DER is equally applicable to the microwave, which was also being done in CCAM. So,
yeah,
that goes to your point about layer 1, commonality with layer 1.
Yeah,
I agree on the parameters. I'm wondering about the model when you want to collect the information, maybe structured in a way that is technology specific, but maybe you can reuse a grouping to get the same attribute and the same definition.
Yeah.
Let's try
and see
we
what
can
you come
try
up with.
and report our findings. Okay.
Thank you.
Thank you.
So
that concludes the second session. See you all in Vancouver.
Thank you. I'm spent.
Both sessions.